Page 2 of Simple Geometric Probability. Now guys, I'm going to show you something. And then I'm going to show you something else, and you're going to be mad at me for this first something. But it's okay. Just bear with me, because we're going to make this work. So a tree diagram is a way to find the number of possible outcomes of more than one event. So our first example, Miguel is going to select an outfit from two different t-shirts, either tan or red, two different pairs of shorts, gray or khaki, and three pairs of socks, black, navy, and white. We're going to draw a tree diagram to represent all possible outfits. So we start with the first thing they give us. So we've got tan t-shirt and a red t-shirt. Once he chooses his t-shirt, he can select two pairs of shorts. They can be gray or khaki with his tan shirt, gray or khaki with his red shirt. Listen, Miguel, I hope you're not wearing a tan shirt and khaki breeches. Right? And then out of those, he can also choose socks. So he can go tan shirt, gray shorts with black, navy, and white socks. He can also do that with his khaki breeches. Black, navy, and white. Same thing if he were to go red first. So black, navy, and white. And then black, navy, and white. So it wants to know what are our possible outcomes. Well, there's a lot of stuff happening on the screen, right? We've got tan, red, gray, khaki, black, navy, and white. Well, how am I supposed to add all those up? We're just going to add up our end. Okay? How many are in our end? So that he can go tan, gray, blue, or black, tan, gray, navy, tan, gray, white. Tan, khaki, black, tan, khaki, navy, tan, khaki, white. Red, gray, black, red, gray, navy, red, gray, white. So if I just count out the end number, the last piece of my tree, the last branches, I see that there are 12 possible different outcomes. Because if he wears tan, gray, and black, he's no longer wearing tan, gray, and navy. So there's 12 possible outcomes that he does this. Okay. What is the probability that Miguel will select tan shirt, gray shorts, black socks? Well, we're asking, okay, the only way that happens is if he goes tan, gray, black. So that is what we want to happen. There's one chance. Total number of outcomes goes on the bottom. We get 1/12. Well, what happens if Miguel goes red shirt, gray shorts? Well, how many possible outcomes were there? So that would be red shirt and gray shorts. So if he goes red and gray, well, there's only 3 possible outcomes. So what we want to happen is there's 3, and then out of those 12 total. So that gives me 1/4. What if Miguel just chooses khaki shorts? How many total could that be? So if he goes khaki with a red shirt, doesn't matter. There's 3. Khaki with a tan shirt, don't do that to yourself, Miguel. So how many total outcomes do we have? Well, there's 6 out of 12, which would be a 50% chance that he chooses that. Let me try to get these guys out of here. Boom. So that is using a tree. Okay? Trees are useful, give us oxygen, but they also help us see all of our options. Now here's where you're going to get mad at me. Because I'm going to give you something called the fundamental counting principle. And the fundamental counting principle is another way to find possible outcomes, especially when there's a large number of them. So we're going possible outcomes. I want you to think of this if you have options. So say you're going to buy a new car. Okay? Money is not an issue. You walk up to the dealer and say, "Look here, homie, I want to buy a car." Well, he's going to say, "What kind of car?" And you say, "I want a F-150. Okay? Now, of that F-150, you've got 4 models. You got the SLT, the Raptor, the Roush, and the XR1, whatever we're going with. That was not an actual model of F-150. I apologize. And of those options, you can have moonroof or not, tan interior. So if you've got options, you can use the fundamental counting principle. And it's going to make your life a little bit easier. So a deli is doing inventory of their sandwich ingredients. They've got 6 types of bread, 8 types of meat, 4 types of cheese. How many different sandwiches can they make? Now you can make a tree. We can list out our 6 types of bread and do 8 types of meats for each type of bread and 4 types of cheese for each type of meat. But rather than do that, we're going to use the fundamental counting principle. And here's where you're going to get mad, because we're going to go back up and I'm going to show you the top 2. So we're going 6 types of bread. That's our bread, right? And we're going to multiply it by our 8 types of meat and multiply that by our 4 types of cheese. BMC, big man on campus. Okay, so 6 types of bread, 8 types of meat, 4 types of cheese. That gives me 192 possible outcomes. Now, if you wanted to make that tree, you'd be writing something. You'd be writing 4 types of cheese 192 times. And that sounds awful. So let's go back up to Miguel, who I'm telling you, I hope he didn't wear that khaki and tan. That poor fella. So Miguel was able to choose from 2 shirts. Those are his tees. He was able to choose from 2 shorts. His breeches. And Miguel had 3 pairs of socks. 2 times 2 is 4, times 3 is 12. So, with 12 possibilities, it wasn't that big a deal. But if I had 192 of them, the fundamental counting principle is going to be huge. So when you have options, fundamental counting principle. This concludes page 2.